Today we're going to look at section 8.5. This is where we're going to apply theorems to establish proportionality. So the theorem that we're going to use in order to establish proportionality is called the side splitter theorem. So I want us to look at this picture, and I'm going to give you a piece of given information and tell you two things then that we know regarding then this side splitter theorem. So I am giving us that the line BE is parallel to the line CD. Okay, so I have to be given parallel lines. So I'm going to mark it in my picture. If I'm given parallel lines, then there are two things that we know. The first thing that we are going to know is that we're going to be able to set up a proportion, and it meets this side splitter theorem, side splitter. Notice how BE is splitting two sides. So that means that AB over BC. Notice I've created a ratio with one side that's being split. That's going to equal AE over ED. It's the ratio of the other side being split. Notice that AB and AE are both the top portion of the sides being split, and BC and ED are the bottom portions of the sides being split. So that's where that consistency stays. The other thing that we're going to be able to recognize is that because I have because I have parallel lines, we're going to get similar triangles. Because essentially, I have this angle ABE congruent to this angle C because those are corresponding angles, and corresponding angles are congruent. I also have another pair of corresponding angles, that angle AEB and angle D. So because I've got two triangles, I've got triangle ABE and I've got triangle ACD, they're going to be similar because there's this theorem called angle-angle, and that's what proves similar triangles. Technically, it's angle-angle-angle. So if you think back to chapter 3 of first semester, we thought about all the ways of proving congruent triangles, and I told you angle-angle-angle was not a way of proving congruent triangles because technically, angle A is in both those triangles and it's congruent to itself. So angle, 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 I've got three different triangles with three sets of congruent angles. Well, that gets me similar triangles. Okay, so those are the two things that I'm going to know based off the fact that I'm given that BE and CD are parallel. So let's use that information and let's do the following. So based off of this diagram, I'm telling you that BE and CD are parallel, and I even have it marked in the picture. I have some of the sides marked as well. AB is 4, BC is 2, AE is 7, BE is 6. We are going to find the length of ED as well as the length of CD. Okay, so to find the length of ED, which I'm going to call X, we're going to use that first half of our theorem, which is that side splitter theorem. I can set up a ratio of the sides that are being split. So notice AC is a side that's being split. That's 4, which is the top portion, and 2, which is the bottom portion. So that's why I get to set up that ratio. The other side that's being split is AD. So 7 goes on the top because that's the top half, and then what I'm calling X, which is ED, goes on the bottom because that's the bottom half. And now that I have this, I can go ahead and I could technically simplify. 4 over 2 reduces down to 2 over 1, and then I can cross multiply. So 2 times X is going to equal 1 times 7, which is 7. I can divide both sides by 2, and X, which I just labeled for ED, is 3.5. So there's my answer for part A. So then if I'm talking about finding the length of CD, well, this is where that second half of similar triangles is going to come into play. So once again, because I have parallel lines, I've got a couple of sets of corresponding angles, and I've got this angle up at the top that's in both of my triangles. So I know that the triangle of ABE is similar to the triangle ACD. So notice that A's are in the same spot because angle A is congruent to itself. Notice that B and C are in the same spot because those are marked the same. E and D are in the same spot because those are marked the same. So notice that when I have similar triangles, I can set up a ratio of corresponding sides, and I can set that equal to a ratio of another pair of corresponding sides. So what I'm going to do is I'm going to name all of the sides of the triangles and put them with their corresponding piece. So AB is going to be corresponding to AC. AE is going to be corresponding to AD. BE is going to be corresponding to CD. Okay, so from that, we really only need two ratios that are going to help us out. So because I know that we've got ED, which is 3.5. That would mean that AD is going to be a decimal. So I would say let's ignore that middle proportion and let's focus on the outer proportions. So AB is going to be 4. Notice that the length of AC is actually me adding those pieces together. 4 and 2 give us a length of 6. That's going to equal BE, which is 6, over CD, which is my unknown. And now I've got my proportion and I can solve. So if you want, we could reduce down. 4 over 6 reduces to 2/3. Then we can cross multiply. So 2 times CD is going to equal 3 times 6, which is 18. And then I'll divide both sides by 2, and I'll get CD to be a length of 9. And there's my answer. All right, so let's take a look at this problem. So notice that I'm given that JK is parallel to NM. Okay, so when I have these parallel lines here, we've got several things that we know. So one thing that we know is that the ratio of corresponding sides, the sides that are being split, are equal. So that means that FJ and JN are going to form one ratio because that's one side being split. And so that means on the other side, FK is going to go over KM. The other thing that I know is that I've got similar triangles. The small triangle of FJK. Notice that F would be congruent to itself. We've got corresponding angles there. We've got corresponding angles here. So that's going to be similar to the triangle. F have to go with F. J has to go with N. And K has to go with M. So there's my other triangle. So those are two things we know because we have those parallel lines. I know that FJ is a length of 10. FK is a length of 8.4. We've got JN, which is a length of 16. MN is a length of 30.2. Okay, so we want to find JK, which I'll call X, and KM, which I'll call Y. Okay, so I think the easiest thing to find first would be actually KM. So to find KM, I'm going to set up the ratios of the sides that are being split. So I'm going to use that first piece of given information. So FJ is 10 over JN, which is 16. That's going to equal FK, which is 8.4, over KM, which I'm calling Y. Okay, if you want, you can reduce down to the 10 and the 16. They're both divisible by 2, so that would be 5 over 8 equals 8.4 over Y. If I cross multiply, we'll have 5Y to equal, 8 times 8.4 gets us 67.2. And then I'm going to divide both sides by 5. And I'm going to get then my side to be 13.44. Once again, it stopped at a nice decimal there. It didn't keep going and going and going. So it's okay if you leave it as a decimal. All right, so then the next thing that I want is to find JK, which I called X. And I'm going to use the similar triangles in order to make that happen. So when I have similar triangles, remember that means that we've got a bunch of corresponding sides. There's ratios that are going to be equal. So I know that FJ is going to be then similar to FN. So those are going to form a ratio. They're corresponding. I know that FK is going to be corresponding to FM. And I know that JK, which is one that we're going to need, is going to be corresponding to NM. So I definitely need that last ratio. I would suggest, once again, since we're dealing with a bunch of decimals, maybe not using that middle one. So I'm going to use the first and the last again. So FJ was 10. And FN, remember, is me adding the two little pieces together. So 10 plus 16 is going to get me a length of 26. That's going to equal JK, which we're calling X, over NM, which is this 30.2. Okay, so if you want, you could simplify down. The 10 and the 26 are both divisible by 2. So that could give us 5 over 13 to equal X over 30.2. And then I can cross multiply. So we'll have 13 times X. And let's see, 30.2 times 5 is going to give us 151. If I divide both sides then by 13, I'll notice that when I put it into my calculator, I'm going to get 11.615388462. So instead of truncating a decimal that looks like it's going to keep going, I'm just going to see if I can simplify down 151 over 13 any further, and I can't. So I'm just going to leave it as that fraction. So 151 over 13. And that's my answer. Okay, let's take a look at this one. So I want to find X and Y. I should have told you, I'm sorry, these are parallel. Okay, so once again, we're going to use that side splitter theorem to find Y. So I'm going to set it up as 12 over 8, because that's one side being split, equals 15 over Y. Okay, you could simplify the 12 and the 8, or you could just cross multiply. This time I'm just going to cross multiply. So 12 times y is going to equal 8 times 15, which is 120. And then I would just divide both sides by 12. And it looks like we get 10 for y. Okay, so now let's go ahead and solve for x. And think about this. I'm going to set up some similar triangles. So because it doesn't really matter, I don't have any decimals, I could use this side or I could use this side. It doesn't matter. I think I'm going to stick with the left side. So I'm going to do 12, which is the side of the small triangle, over the side of the really big triangle, which is me adding 12 and 8 together. So that's over 20. Then going back to the small triangle, I need 17 because that's going to be corresponding to the big side at the bottom, which is X. Okay, so you could simplify the 12 and the 20 down. 12 and 20 are both going to be divisible by 4, so that would give us 3/5. And that's going to equal 17 over x. When I cross multiply, we'll get 3x to equal 5 times 17, which is 85. I'll divide both sides by 3. And 85 divided by 3 is not a pretty number. It's 28.3 repeating. So once again, because I've got that decimal that keeps going and going and going, I'm going to leave it as a fraction. It doesn't simplify any further. 85 over 3 is going to just say 85 over 3. And there's my answers. All right, here's our next one. I want to solve for x. Notice that I'm giving us those parallel lines, so we can use that side splitter theorem. So I want x over 6, because that makes up the sides of one of the triangles that's being split. That's going to equal x plus 1 over 9, because that's the other side that's being split. Notice that x plus 1 is a binomial, so I'm going to put it in parentheses. So then when I cross multiply, we'll get 9 times x to equal 6 times that whole entire quantity, x plus 1. I'm going to distribute the 6 to get 6x plus 6. I'm going to subtract the 6x from both sides. That gets me 3x to equal 6. And then I'll just divide both sides by 3. They just wanted us to solve for x, so I got x to be 2. I'm done. All right, last problem. Here's a multiple choice one. It says, in the figure to the right, AC is parallel to DE. Okay, so I marked it in my picture. So what is the length of DE? I'm going to call that X. And remember, this is dealing then with the fact that I don't have any information on the left side. So we're not doing the side splitter theorem, but I need to know that because I have parallel lines, I'm dealing with corresponding angles that are congruent. And so essentially, I've got two triangles that are similar. So the triangle of BDE is similar to the triangle. So I got to put B first because B was congruent to itself. I got to put A next because A and D were congruent, which means I have to put C last because E and C were congruent. Okay, so if I look at all my sides, I know that BD is corresponding to BA. That's going to equal BE, which is going to be corresponding to BC. And DE is corresponding to AC. So I definitely need to use the last ratio because we're trying to find DE. I think I'm going to then stick with these two because, like I said, I don't have any side lengths for BD or for BA, so that's not going to be useful to us. So BE is 10. BC, be careful. I have to take the whole entire side. So that's 10 plus 5. So that's going to be 15. That equals DE, which I'm going to call X, over AC, which is 18. So I'm going to then simplify 10 and 15. That simplifies down to 2/3. And then I'm going to cross multiply. So we'll have 3 times X to equal 2 times 18. Well, 2 times 18 is going to be 36. I'll divide both sides by 3. So it looks like X equals 12. Once again, X is representing DE. DE is what I was trying to find. So it looks like C is my answer. So that's us applying theorems using proportionality.